Now this is another old video from my archive, and it was taken I believe in 1994, and one of my daughters took this video. Now this boiler is for a 7¼ inch gauge Derby 4F. Now, if you know your locos, the Derby 4F had a Belpaire boiler, big square casing at the firebox end, and this particular model was designed with a round top boiler to make silver soldering a lot easier, and the construction of the boiler a lot easier also. When the boiler was mounted on the engine frames, it was then encased in the typical big square pleading like you see on the Derby 4Fs. Now all this braising took place in my old workshop, as I say, many years ago. I no longer have this old workshop. I say we moved from this place a long time ago. I've always done my tube plates like this, vertical, and then held by a clamp. This method ensures that the silver solder runs round the tube ends, and you can clearly see then where everything's run. This video is not a complete video of boiler making. It's just a few clips what was taken at the time. I'd actually made the flange plates for this boiler in late 1991, and for various reasons the job was put aside. And I was also running my 7¼ inch gauge Romulus at this time, and various other projects were going on, and it was put to one side until 1994, when I commenced finished the construction of the boiler. Here's a better view of the tube plate now it's been silver soldered. When the boiler was assembled and finished, there was no leaks on this tube plate at all. It was tight. There's the assembly, the firebox, just doing a trial fitting of the tubes and tube plate. I'm now silver soldering the firebox door plate. The stuttering sound is not the blowtorch stuttering, it's just the sound recording. I don't know why it was doing this, but that's what's causing this unusual sound. This severt torch and the various nozzles which I had in stock handled the silver soldering of this boiler quite well. It was no problem really. It got the heat there. I'm just using my Tom Senior Miller, the vertical head in the horizontal position, and using it like a horizontal borer, just to bore out the steam dome opening. I found this the easiest way. Just chain drill the hole and then knock out the piece, and then just put it on the miller and let the miller do the work. The whole tube was securely clamped to the milling machine table by a long bolt and a flat piece of bar across the tube end. And this did okay.
Try and get that. See, the silver solder was not right tube ends through flanges. Crown stays.
Well, as you can see, this design used bar stays instead of girder stays connecting to the outer wrapper. Now, our boiler inspector, Peter Vary, was a professional boiler inspector who inspected loco boilers and industrial boilers, and he approved the design. Well, it was subsequently a whopping great lump of copper to get warmed up to get the silver soldering done, but it was done successfully with the severn torch. And there's the smoke box and tube plate. Well, here's a view of the boiler, a mock-up, stuff, all the inner firebox inserted and making sure everything fits alright. The outer shell of the boiler with the bushes braised in. Everything where it should be. A little bit of almond rock there, but won't be helped. The silver solder penetrated through okay. Here's a view of the butt strap on the underneath of the boiler, fully silver soldered. Our boiler inspector was very keen that this was on the outside and plainly visible. I think some people put them on the inside of the shell. I'm not too sure about that, but I do know also that a lap seam is sometimes used with the rivets. There's a view of my old braising hearth, which was originally the old fireplace. This was in the old washroom in the basement. It served its purpose and all the fumes went up the chimney. There's my silver solder. Not easy flow, but equal to easy flow. A very good stuff it was. Still plenty of silver solder left. Very expensive stuff, and I believe it's even more expensive today. There's the old faithful severn torch, and this is the largest nozzle. It's like a V2 when that's going. As I mentioned earlier, I put the flange plates well before I started on the main boiler. And you can see I'm re-annealing one of the plates and partially flange. Now I use steam hammers, every steam hammer for flanging large plates like these, because it's fairly to keep cooking. Wooden hammers and mallets and hide hammers and whatever just don't do it. Just will not do anything to the copper, especially thick copper. Maybe the thinner plates would be okay. I've always used steel hammers. The formers I was using were made of MDF. I didn't use steel or iron plates, and the MDF did the job okay. With it being just one-off plates, they did the job, and the formers survived okay. There was no damage to them. As to flange the boiler plates, all the flange plates on this boiler, I didn't use any made of steel or iron. I just used dense MDF and wood, and it performed quite well. It did the job. Basically, they were only one-offs, so it lasted. Just be careful clamping and everything, and the flanged okay with these wood formers. Well, it must have been my youngest daughter doing the filming, because the eldest daughter's just been shouting down to her. And incidentally, both my daughters enjoyed driving my Romulus engine at this time. And they also drove this Derby 4F when it was completed. And now the hammer work starts. These hammers which I was using, I'd modified these. I'd ground the front faces of them, and one of them had a slight curve on. This made it easier to do the flanges. Well, I found it easy anyway, and they didn't leave any nasty marks or dents in the flanges. It's really quite satisfying when you're bashing copper like this and then you see it forming. There's a view of the hammer with the specially treated front face. It has a slight curve on it, and that was highly polished. I actually used two hammers. When I flange copper plates, I usually hit them like a glancing blow, really, not direct. I find this forms the flanges easier. By the sound of it and feel, it's ready for another anneal very shortly. This is a view of one of the firebox plates. It's always a little bit tricky to do. Now what I'm doing here is using my boring head in the vertical attachment on the miller, and I'm actually boring out the holes for the bushes in the back head. I've already done the fire hole door to take the fire hole ring. I find this method a lot easier than trying to drill out holes to size, because, as you know, copper is notorious for drilling and reaming. All I do is just drill out a pilot hole and then open out with the boring head. At this period in time, I didn't have access to making my special counter bores or pilot drills, which, if you've seen one of my earlier videos, you'll see how effective they are at cutting large holes, and they would have cut through the copper quite cleanly. Now, our boiler inspector insisted on using bronze stays. It wouldn't allow the copper rivets to be used. It's quite a tedious job machining these stays, and then I had to put a thread on them. But I suppose really in the long run bronze is better than using copper rivets. I suppose I could have put plain stays through instead of threading them, but I preferred the threaded stay. I don't do any boilers now, but over the past 4 or 5 years I have actually built 3 boilers of the Martin Evans design, one for his B1 and 2 boilers of the Waverley, all these in 5" gauge. And in these boilers I have actually used copper rivets as stays. These were completed for a friend of mine. Well, here's a view of the turned bronze stays prior to threading. There's the steam dome. Just a view of the tube plate, all silver soldered. I put a little bit too much silver solder on there, but it doesn't really matter. There's the top bushes all soldered in place. There's a view of the threaded stay holes. I made a special tap for these, a guide tap. I ground a guide on the front of the tap, ensuring that they were parallel all the way through, both outer and inner wrapper of the firebox. Now this is the first boiler test I did before our boiler inspector did the actual test. I pumped it up to I think it's £200, and I just left it for half an hour, and there was no leaks whatsoever. We're very, very pleased with the result. Probably if I had access to oxyacetylene, it would have probably been a bit neater looking. But using propane, you've not got the control like you have with oxyacetylene, and sometimes you can be a bit messy with the runs. But not too bad really. Now this is a trial fitting in the engine frames. Everything seemed to fit okay. There were 1 or 2 minor adjustments, but no, there were really no problems. There was still a long way to go before the engine was completed, but once it was finished, it ran okay, and it was very enjoyable to drive. I sold it many years ago. I'd be interested to know of its whereabouts today. I built this engine as the original type of Midland engine with a Midland chimney and dome, as well as the flared Midland tender, which there's not a right lot of these about, I don't think. Now this is a view of the smoke box fitted to the chassis, and this compound I used, I found it very good for sealing. I used it to seal the floor of the smoke box. This saved me a heck of a lot of work fitting various plates and odds and ends to seal the smoke box. I just used this compound at the bottom, and it sealed everything perfect. And it was semi flexible. It never really went solid, so if you needed to remove it, it was easy. There's a view of the valve gear and the twin lubricators there. And the crank axle. quite a lot of work involved producing that. Here's another view of the ceiling compound which I used. Whether you can still get it today, I don't know. It was very, very, very good. Well, I hope you found this of interest, and thank you for watching.